Welcome to all. Myself, Dr. Vishwanath P. Department of UNC, Raju Institute of Technology, Hassan. Today I am going to explain and demonstrate how to design and test the precision of wave and full wave rectifier using op-amp in multi-sim. So all of you know the working principle of the rectifier. So what is the difference between the rectifier and precision rectifier? First, let us understand the rectifier. A rectifier is a circuit that converts AC to DC, with alternating AC to DC, and in rectifier circuit, the alternating current always changes its direction over the time, but the direct current flows continuously in the one directions. So typically in rectified circuit, we use the diodes to rectify AC to DC, but in this time the rectification method can only be used if the voltage to the circuit is greater than the forward voltage of the diode. So that means you understood that. Always the threshold voltage will consider. So that is, if the input voltage is greater than the threshold voltage, then only the forward voltage or forward current will be flow in the diodes. That is, typically the threshold voltage is 0.7. We lose some voltage in the output side. That is the major drawback of the rectified circuit. To overcome this issues, so we use the precision rectifier circuits. So in this precision rectified circuit, it is also convert AC to direct DC. This precision rectified circuit is also convert the AC to DC, but in a precision rectifier, we use an op-amp to compensate for the voltage drop across the diode. So without any losses of the voltage, we get the output voltage. So we're not losing any threshold voltage, that is 0.6, 0.3, 0.7 voltage drop across the diodes. So this circuit constructed to have some gain at the output of the amplifiers. So the main purpose is without any voltage drop, we can across the diodes, we get the output. So according to the input signals. Now an alternating current always change the direction. Good. So understood that. Now this is the simple rectifier operation. See, from the screen you observe the circuits. So this is the diode circuits. Okay. So this is the ideal transfer characteristics. If I am considered for practical, some voltage drop occurs. See in the output, see 0.7 voltage. That voltage drop. So red color indicated the actual signal value, but yellowish color indicated the voltage drop. Okay, and also the transfer characteristics also shifted to the right side. That is, after threshold voltage, then only the diode is conducted, and it is exponentially varying the signals. Okay, this is the drawback of the rectifier circuit. So that problem issues overcome by this precision rectifier. So it is very useful for high precision signal processing. Mainly, there are two types of we are classified in precision rectifier. One is half wave, and another one is full wave precision rectifier using op-amp circuit. Let's discuss the half wave precision rectified circuits. So the circuit, observe the way in the screen. So it is a simple half wave precision rectified circuit. Okay. So this circuit produce the off wave of the input signals. Okay. Now, so that observe the operation of this, how this circuit is operated. Let's see that the diode D2 will conduct it if the positive off cycle of the sinusoidal signal is applied. when positive off cycle is applied to the circuit, the D2, diode D2, so from the figure you observe that D2 is conducted, and the, the showing path from the yellow color line indicated in the figure, you observe that, okay, is so this path is acting as a inverting amplifier. So complete uh, uh, the above shown path is when it is completed, and the op-amp is acting as an inverting amplifier. And at the point P1, so from the figure you understood that in the terminal 2, okay, the point that is 0 volt I am showing here. So that is point P1. The volt at that point, the voltage is 0 volt, and we called it as a virtual ground. That is, virtual ground is formed at this point. So current cannot flow through this resistor R2. So through the resistor R2, there is no current will be flow. And in the output point P2, so the op-amp output point, terminal 1, you observe that point, the output point P2, the voltage is negative 0.7 volt, as the op-amp is compensated for the diode drop. So there is no way that current can go to the point P3. So never, so any current will go to that point P3. So that is how we have achieved as a 0 volt output whenever a positive off cycle of the signal is applied to the input of the op-amp signals. So next, let's assume that negative off cycle, what happens? Okay, this is positive off cycle. So from the graph is also observed, during the positive off cycle, there is no output voltage, 0 output voltage is produced. Okay, so because P1 is virtual ground is there, so 0 volt, and so there is no current will be flowed through the resistor R2. So then output point P2 is in negative, so 0.7 voltage is there, as the then op-amp has compensated for the diode drop, and there is no way the current can go to the point P3 also. So therefore output is also 0 volt. At P3 you get 0 volt. So when assume that negative off cycle sinusoidal signals in to the input of the op-amp, so minus and plus we provided, so that means negative off cycles we provided to the input of the op-amp circuit. Now what happened? At this point, the diode D2 is in the reverse biased condition. So diode D2 acts as in a reverse bias conditions. So this is the D2 acts as an open circuits. This just you assume that open circuit. So then understood that. So when it is diode D2 is in reverse bias condition, the current will flow through the resistor. Through the register, where? Through the R2. So when it is acts as a open circuit, then definitely the current will flow through the resistors R2, forming a virtual ground at point P1. Now when the negative off cycle of the input signal is applied, we will get the positive signal in the output as an inverting amplifier, and the diode will conduct it, and we will get the compensated output at the point. So this diode D1 is conducted, and the compensated output, whatever output is obtained here in the point P2, that output is appeared in the P3 is also without losing any output value. Okay, so now the circuit, okay, operation. So output voltage in from the waveforms also you observe that what during the negative off cycle, positive output with the 180 degree phase shift you get it. Okay, output voltage. So this is the half-wave precision rectifier circuit operation. I hope you all understood that. Okay, let's see the practical component. Okay, so this op-amp I am using, and two diodes are connected. And resistance for capacitor purpose, I connect a resistor. Okay, Uh, so this is the previous one. Okay. So diode D2, D1. So here also, okay, this is D2 and D1. Okay. Uh, from the figure what we observed. Okay. But the name is different in the practical component. So D1. So feedback, and this is the resistor. Understood that. And so load resistance R3, R3, okay, and R1, okay. Uh, just I will, so full wave precision rectifier. So before that, I will explain how, okay. Um, so circuit, just I change the label because according to our explanation, this is D1 circuit and this is D2 circuit, okay, D2 diode. Now, so use 741 op amp. Supply voltage is 15 volt connected VDD and VE, and connected 1 kilo ohm resistor. Okay, and diode D1 diode is 1N4007 and D2 1N4007. So now, so feedback resistance is R2 1 kilo ohm. So observe the output during the negative off cycle. Diode is a output voltage is obtained. During the positive off cycle, output voltage is 0. Okay. Just after construction, the circuit diagram of a precision rectifier. So just you go to simulated, analysis and select the analysis and simulations, and okay, not run the, just run it, and where you observe output, you observe in the CR. So indicated for in red color is input. So I change the output line. Okay. See, blue color signals indicated output, red color indicated input signal. Similar way, we can constructed the full wave precision rectifier. Full wave precision rectifier. So full wave precision. Next, consider the first off portion is the off wave precision rectifier. This off wave precision rectifier outputs are connected to the another inverting amplifier circuits. Another inverting amplifier circuit, we get the complete signal. Okay, output signal, positive and negative off cycles without losing any voltage drop. Okay, see, so first off is connected to the first off is off a precision rectifier circuit. So this circuit is once again P1 point connected to the negative terminal of the second op amp. So it is a negative inverting amplifier. So circuit, practical circuits I connected here. Okay, and observe the oscilloscope output. So red color line indicated signals indicated the input signal, and blue colors signals are output signals. Okay, I'll show in the so this is my sorry sorry. Shit. So this is my full wave precision rectifier circuit. Observe the output. Yes. Okay. So this is my circuit. So first off is the off wave precision rectifier. The output is connected to the second inverting op-amp circuits. Okay. So 5 volt peak to peak one signals I am using AC signals, AC voltage, and observe the output. So red color indicated the input signal, sinusoidal signal, and output signal. Blue color signals are output signals. Produce the both positive and negative of cycles. So thank you. I hope you all of you understood the how to construct it. Precision rectifiers, both off wave and full wave precision rectifier in a multi-sim environment. Thank you for watching video.